So it's 11, so let's start. Welcome, Tomáš.
My name is Tomáš Mráz. I work in Red Hat Czech in Brno, in Czech Republic, and I am a principal software engineer in the crypto team. Basically, we work about all the crypto technologies in Red Hat Enterprise Linux, and also Fedora, of course. What we will be discussing today, we start with some motivation. We will talk about crypto policies in general, about custom crypto policies, which is a new addition to this tool, and we will also talk about, we will show some examples of custom crypto policies. We will talk about future a little, and there will be summary. For the motivation, cryptography and cryptanalysis goes hand in hand, and basically the evolution of algorithms and protocols is faster and faster. You can never be fully sure that once you deploy something that in next year it will be secure enough. So you need to accommodate for the changes. Here is some example of changing technology in terms of crypto protocols, TLS. You can see here how the protocols were, when the protocols were standardized and when they were insecure. That's basically where the line stopped to be full. When they found to be insecure. Of course, they were insecure from start, but nobody knows that. So we currently have still 1.2, which is fairly secure still, and 1.3 is new thing. So you have some pretty nice guides how to set up your web server, SSH server, whatever other application, how to set up it so it's very, very secure and uses the up-to-date algorithms and protocols and so on. But these guides, here is one of the example, are very, very long, and you have to go through them, set up, change configuration files, so on. What if you need to apply these crypto settings and changes for the configuration regularly to hundreds of machines, various kinds of machines on your network, and some of them are virtual machines maybe, and containers or whatever. And the other thing, to complicate things even more, various machines usually have different needs or levels of needs to communicate with legacy devices. Various old hardware, Cisco boxes, I don't know what you can have on your network. Crypto policies come to rescue because they are centrally managed on the system. They provide you multiple pre-designed policy levels, and they also simplify FIPS support if you care about it. If you are enterprise, want to sell to U.S. government or related institutions. Central, what does it mean? It's central managed on the system. There is a single command, update crypto policies -- set, and you provide a level you want to set on your system. This single command manages configuration for all these core crypto libraries, as we call them, and also some applications on the Fedora or RHEL system. These are basically all the core libraries that are used by the base system applications. So when the update crypto policies command runs, it transforms a simple policy definition file into separate configuration file snippets that are loaded and or included by the configuration files of these libraries or applications. Let's talk about the levels that we provide, which we are kind of pre-designed. The most lenient level is legacy, which provides you 64-bit security about. It also enables RC4 and 3DES, but only for some applications. For the applications or libraries where we decided that it's not longer relevant at all, it's also disabled for these. The default level, here are the levels for Fedora actually. The default level still enables TLS 1.0 and TLS 1.1, but disables all the RC4 and 3DES. The next policy level, which is actually the default for Red Hat Enterprise Linux 8, enables only TLS 1.2, and it also requires Diffie-Hellman parameters to be larger than 2 kilobits, the same for RSA and DSA. But there was, at the time when we started, for Fedora it was not acceptable because it still broke some websites. But I suppose that in the next release we will drop or change the default for Fedora as well to this level. The future level is kind of special because it allows you to test whether your application or system or whatever is prepared for some of the future changes. Of course, it cannot enable things that are not implemented in the libraries, but it at least drops supports for 128-bit symmetric ciphers, which basically, in this particular part, it will prepare you for post-quantum situation. And the FIPS policy is special because it removes support for all algorithms that are not approved for FIPS. The simplification of the FIPS mode with the crypto policies is provided also by having just a single command that will enable the system FIPS mode for you. Because previously, for example, on Red Hat Enterprise Linux 7 or older releases, you had to follow a few steps that you would have to do to enable the system FIPS mode. Now you just run a single command and reboot. So to summarize, the system crypto policies provide central management on the system by single command that controls all the core crypto libraries and applications using crypto. There are multiple pre-designed policy levels which provide up-to-date security, also communication with legacy systems or preparation for future. And there is a FIPS support provided as well, and simplification of the FIPS mode enablement. And where you can get this tool on current Fedora versions or all the supported Fedora versions and Red Hat Enterprise Linux 8. But what if the predefined policy levels don't match your requirements? Now custom crypto policies come to rescue, which is a new improvement of this tool. With this feature, you can define your own crypto policies from scratch, or you can modify existing predefined policy levels. How to do that? When you define your full policy from scratch, you place place the full policy definition file into one of these two directories, and the file needs to be named policy.pol with the uppercase in the name, in the file name is important because otherwise the tool won't recognize it. The format of the file is kind of simple, although you of course have to know the names of the algorithms. But as you can see here, you have hash. It's a simple like key equals value format where most of the values are lists of algorithm names, such as here we can have all the various hash algorithms. This is actually excerpt from user share crypto policies future poll, and provide, as you can see, only SHA-2 and SHA-3 hashes are enabled in the future policy. Here is the setting for key exchanges. This is the group key. Again, you can see here that these are the Danvers or the safe crypto curves, and here are the normal NIST curves and normal Diffie-Hellman parameters of these lengths. And in future policy, you can see the minimum TLS version is 1.2. Minimum size of the RSA keys are 3 kilobits. Of course, there are other values for symmetric ciphers, signature algorithms, and other parameters. But you might probably not want to design your policy from scratch, full policy from scratch. One of the reasons why not to do that is because the various crypto backends have, or the way how the policy is transformed into the actual configurations file for the libraries has some limitations. Basically, the limitations are due to the way how the libraries are being configured. We did not, we added some changes, but we did not try to really reinvent all the configurations for all the libraries. So there are definitely some limitations on what you can set with one library and another. And for that reason, it might be a good idea to just modify existing policy with the so-called policy modifier module. These modules need to be placed into the modules subdirectory, and they have a different suffix pmod. Again, the uppercase in the name of the module is important. So here will be some examples of the modifiers. For example, you can disable SHA-1 hash. You just basically apply these changes to the original policy. That means minus SHA-1 means remove SHA-1 from the list of the hash algorithms. Minus RSA PSS SHA-1, RSA SHA-1, ECDSA SHA-1. Remove these signature algorithms from the list of signature algorithms in the base policy. How to apply this modifier? Basically, with this command, you append with a colon no SHA-1. You append it to the base policy, and the policy will be modified accordingly. You can, of course, there is no limitation on if you have a module on which base policy you apply it. It can be applied on any other policy like future. But in future, for future policy, it has no effect because there is already, the SHA-1 is already disabled there. Another example. By default, Camellia is enabled only for like non-TLS applications or protocols. With this plus name of the algorithm, you add it to the list of the enabled algorithms for TLS. Here, just for, there is no problem if you just, if there in the base policy, if the Camellia is already enabled, if you add it again, there is no like error or no problem with that. So it's a good idea to be for sure that I enable it everywhere. I put it for both TLS and non-TLS ciphers. The other option is to put the plus on after the name of the algorithm, which just changes the order where the algorithms are put. Because if you put the plus before the name of the algorithm, it will be inserted on the beginning of the list. If you put it at the end of the algorithm name, it will be put last or appended to the list. You can, for example, disable all TLS protocol versions in legacy policy by these settings. There is a kind of duplication because some of the backends of the libraries don't allow to selectively disable protocol by protocol. And for these backends, there is the min TLS version or min DTLS version. For the others, you can like selectively use this list to disable all the protocols you don't want. SSL3, by the way, is already like dropped, removed, disabled. No need to disable it anywhere because it's already dropped from the libraries. Here is another example to just make the future policy a little bit more lenient, because by default, or most of the websites have only 2 kilobits RSA keys for certificates. And so this is the most probable reason why, if you set future policy, you won't be able to connect to many websites. So you could adjust your the future policy with this modifier, and you would be probably almost possible to use for future policy for like regular web browsing. Or you can only allow, for example, ECDH and ECDH with pressured keys. This is basically the situation for OpenSSL on TLS 1.3 already, because it does not support the FFDH groups and on TLS 1.3, and it supports only forward secrecy enabling key exchanges. So this, by this way, you just remove all the remaining algorithms from the key exchange. There is a kind of deficiency because what would be logical, more logical would be to have the policy modifier to just set the ECDH and ECDH PSK to key exchange, but the current version doesn't support this. The policy modifiers can be applied, like multiple policy modifiers can be applied at once. So basically, you just put all these one after another. The important thing to understand is that the generation of the actual configuration files for the libraries is done at the configure time, basically when you run the update crypto policies script. This is important because this allows for like changing things in new versions of the update crypto policies. tool. For example, OpenSSL backend could allow more fine-grained selection of the algorithms, because currently it's kind of simple. Or even new backend could be added to be supported. For example, we are planning to have, for example, Go language supported with a separate configuration. So you would not need to like regenerate your policy files or whatever. You would just automatically on the upgrade of the package, the configuration will be updated and everything will be good, hopefully. So to summarize, with custom crypto policies, you can define your crypto policy from scratch in a simple policy definition file, or you can modify existing predefined policy levels by adding or removing enabled algorithms or protocols. And the generation of backend configurations is done when updated the policy script is run. The future plans. One big thing ahead is handling of SHA-1 deprecation. This is one of the reasons why we need to change the backend for OpenSSL. We need to be able to basically selectively disable SHA-1. Currently, this is not possible easily. And yeah, that's basically what I've already talked about. The fine-grained backend configurations for GNU TLS is already improved. It was in previous versions. It was on the more similar level to OpenSSL. Yeah, we would like to at some point think about data at rest support, but that's a much harder topic. Currently, mostly the crypto policies affect only the protocol usage of our algorithms in data in transit. So, quick summary: single command to rule them all, the algorithms and libraries, multiple pre-assigned policy levels, custom crypto policies can be created from scratch or by policy modification, and there is simple policy definition format. Thank you. Any questions?
Do these policies also apply to containers running on the operating system?
They would apply to containers only if you inside the container you have the system with the policies. Basically, if you have Fedora inside the container, then or RHEL 8, you will have crypto policies. It depends on your use case.
Is there any support to distinguish between client and server connections? So, say you're trying to insist that clients connect to your service with this particular level, but then your service then has to connect to another service with a different level. Does that make sense? So you're talking to a legacy system, say.
If you have like multiple systems connect, like
well, just between the connecting client and then say your service has to then connect to another legacy service which has you can't control the crypto you can use on it.
Yeah.
Can you define a policy for the incoming connections to be at a high level, say for the clients on the general internet, but then you can have a lower level for your connecting to your legacy?
I don't really, maybe I don't understand the question really, but basically the policies apply to the whole system. They don't like selectively apply to servers, clients, whatever. They are like kind of general things to be simple, like for the admin to select. So. Okay. So if you have any questions further, I will answer it outside.